Hey everybody, it's Ned Bellavance, Ned1313 on Twitter, and welcome to the Daily Check-In for October 13th, 2020. It's Tuesday, which means it's Terraform Tuesday. And this Tuesday, I'm going to be talking about the Kubernetes operator for Terraform. What's that all about? That's an interesting thing. I kind of mentioned it last week and I decided that's the thing I wanted to pursue this week. I do have now a backlog of 3 other things to cover because of some suggestions from viewers. So thank you. Keep those suggestions coming. I want to know what interests you in the world of Terraform and maybe try to dissect it a little bit for you. But today we're going to talk about this Kubernetes operator. Before we do that, quick housekeeping thing. I still have my Terraform certification guide. I always include it as a link in the description. So if you're looking to get your associate level certification for Terraform, hey, go get it. Also, if you happen to be watching this today or tomorrow, HashiCorp Digital, HashiConf Digital has kind of kicked off today, but it really kicks off tomorrow and it goes through that. And Thursday, I will have a lightning talk on Thursday at 3 p.m. or 3:05 p.m. Eastern time. So if you're interested, you can register for the lightning talk. You can see me talk about an interesting thing I did with Vault and Azure container instances. So that's all I have. Let's check in. How you doing? How's it going? I'm feeling pretty good. I'm feeling good about this day. I started doing this new thing. I've heard about bullet journaling, and I don't really understand what that is, but I started, instead of trying to use electronics for all of my to-do lists and stuff, instead I've just added a to-do list to this daily journal thing. So every day I'm writing down a to-do list of things to do, short-term and long-term, and then each day I recreate that list. I copy it over, and that gives me a chance to think about the things in the list, prioritize them, move things from short term to long term. I really like it. I'm a few days in and I already feel better about my day. So that's how it's going for me. Hopefully you've discovered something cool that makes your life better. If you have, let me know about it. Cool. Let's talk about this this Kubernetes operator for Terraform. So to get this out of the way first, yes, you can create Kubernetes resources using Terraform. There is a Kubernetes provider for Terraform. This is not that. That's not what we're talking about. What we're talking about is creating an operator and custom resources in Kubernetes to then hook into Terraform and deploy infrastructure. Why would you do this? What's the point? It seems like a lot of work, a lot of abstraction there. It's like an abstraction on top of an abstraction, turtles all the way down. Okay, so here's the general thinking. I have defined my application. Let's say I'm going cloud native, Kubernetes all the way. I'm a developer and I like defining my application in YAML in a manifest that I submit to Kubernetes to generate that application. But the infrastructure to back that application might not all live in Kubernetes. I might want to hook into Cosmos DB on Azure or RDS on AWS or some other third-party service that Kubernetes doesn't really have a way to provision. Here comes Terraform. It has a way to provision that. So using the same manifest or the same Helm chart, I can have something sort of provision the infrastructure that backs my application and then provision the application. So that's kind of the idea. Now, where is this actual Terraform provisioning happening? And this was a point of confusion for me. At first, I was like, oh, I get it. I install this operator and then I create this custom resource and then it'll spin up a Terraform worker container inside my Kubernetes cluster. And that Terraform worker container will go and create that config and store the state in a config map or something like that. No, what it's actually doing is it does have the operator that's running on your Kubernetes cluster and you're creating a custom resource. So all that is correct. But it hooks into Terraform Cloud to actually do the running of the configuration and to maintain state and variables. So what you're actually doing is you're creating a workspace object in Kubernetes, which corresponds to a workspace in Terraform Cloud, and you're loading it with a config. And just like as we've seen with previous Terraform Cloud configurations, you can kind of do a local file thing, you can do a Git thing, or you can reference a module on the main repository. Those are your options. Okay, so that's what it's actually doing. Now, in order to install the operator, you need to run a Helm chart that installs all the custom resources and the actual container, or I should say pod, that's running this operator. And then this operator has a webhook that just looks to see if a new workspace has been added or an existing one has been altered. And if it has, then it runs through its process of updating what's happening in Terraform Cloud. So let me go ahead and share out my screen. There we go. This is the actual GitHub repository for this Kubernetes operator. And they do have some directions here and talk about the use case a little bit, all that kind of jazz. To me, it was a little bit confusing. There's also a page here on the Terraform docs that walks through setup instructions for the operator. And I'll include both of these down in the description so you can look and see if they're useful to you. But I thought maybe I would set it all up in VS Code and walk through it. Now, this is going to be a little bit longer in terms of videos, but I think it's worth it. So I'm going to assume you already have a Kubernetes cluster available to you to install all this stuff. You can spin one up in one of the clouds. You can use Minikube on your local laptop. That's what I do for a lot of my testing. In this case, I'm actually using an Azure Kubernetes services cluster, an AKS cluster. But yeah, it doesn't matter where the cluster is running as long as it can get out to that Terraform workspace and talk to that. So as long as it can egress traffic, you're in good shape. The first thing you need to do is create a namespace for where this operator is going to live. You're not going to deploy it in the default namespace. So in this case, I'm going to run kube. Actually, let me just bump this up a bit because it's a little hard to see. There we go. I'm going to do kubectl create namespace, and I'm going to call my namespace tfops because this is the Terraform operator. And then you have to create a secret. What's this secret? What's the point of this? This is the API key that allows the operator to talk to your Terraform Cloud organization. So you're going to have to go over to Firefox, or not Firefox, you're going to have to go over to the Terraform Cloud. This is the Terraform Cloud here, and go into your account. I'm signed in as myself. Go down to tokens, and you're going to have to provision an API token here. Grab that value. All right, now back in Visual Studio Code, I have a credential example file here that sets the token value. So just replace that API token value placeholder with whatever that token ends up being, and then save this file as just credentials. Drop the example. Back in our commands, now we're going to create a secret in Kubernetes that the operator looks for so that it can retrieve those API credentials and talk to your workspace or your organization in Terraform Cloud. So we're doing kubectl create in the namespace tfops. It's a secret of generic type. We're calling it Terraform RC. That's the one that the chart looks for by default. And then what information? We're getting it from a file called credentials, and it's going to, the key is called credentials, and then the data is in the file credentials. So that's the secret that we're creating. Now, because my configuration that I'm going to deploy is using Azure as my target, I'm going to create a virtual network in Azure as my example for this. I do have to create some credentials for it to talk to Azure. So when you're using the Azure provider, if you're going to use a service principal, you need the client ID, the client secret, the tenant ID, and the subscription ID. And all of that information gets stored in variables. We're going to use environment variables to do that. So the first thing I need to do is get my subscription ID. So that's what this portion is. And you've seen this before. I'm not going to go step by step through it. We're going to create a service principal called tfops-sp and give it contributor access to our current subscription. You can change that to whatever makes sense for you, but for demonstration purposes, this works for me. All right, now when we do that, we're going to capture the output of that CLI command in this variable sp and then extract the information we need for our provider from it. So we're going to get the client ID, client secret, and tenant ID. I'm going to assume you're running this from like a Linux or Mac OS command line. If you're on Windows, just fire up WSL and make sure that you have JQ installed, and it'll work fine. You can do it in Windows, but it was honestly a little more difficult. And I've just gotten so used to using WSL. It's what I do now. All right. Now, how are these values going to be referenced by our workspace? Aha, we can use a config map. So a config map is really just a set of key value pairs, a map of key value pairs. And we are going to generate a YAML file with those variables, with those values in it. So we're going to use cat and then do this here doc syntax to redirect the output into this file, environment variables .yaml. And in there, we're going to tell it that it's a config map called Azure-configuration. And in there, we're going to include 3 data points: the tenant ID, subscription ID, and client ID. Now you might say, hey, wait a minute, what about the client secret? We're going to store that in a Kubernetes secret because that's sensitive data. And you could actually create a secret for each of these because you can think of it as sensitive data. But in our case, we're going to store these just in a config map. And we'll see how we reference that config map in a moment. In order to create it, we'll do kubectl apply -f and give it the YAML file that was just generated and put it in the namespace tfops. Everything should be going in the tfops namespace. And then we're going to create a secret in the same thing, and it's going to be this generic thing called workspace secrets. So the operator looks for this secret, and when you refer to a secret in your workspace, it's going to look through this list of workspace secrets and try to find one that corresponds to the value you put in there. So in our case, the key is going to be client secret, and then we're going to store the client secret from the service principal that we created in here. So all of your sensitive data, you can just add additional entries to this workspace secret. Now, when you do this, they do have to be base 64 encoded. kubectl does that for you, but if you're directly editing this secret using kubectl edit, you're going to have to base 64 encode whatever value you're putting in there. All right, now we're going to install the operator. That's pretty straightforward. You add the repository where the operator lives, and then you make sure that you're using the development platform. So you just make sure it's there. And then lastly, we're going to install the development in the namespace tfops HashiCorp Terraform, and we're going to have it automatically generate a name for this deployment so we don't have to give it one. That's all there is to it. The operator is now installed. Now we can get on to actually deploying something to our workspace, and we're going to do that using this vnet.yaml file. Wow, I'm at 13 minutes, but this is where things get interesting. So this vnet.yaml defines a workspace, which has a Terraform configuration in it. Now everything kind of starts coming together. That config map that we created for some of our variables, we're going to use that. That secret that we used for that client secret, we're going to be using that, and we're going to be deploying all of this in a workspace. Now, what's the name? So the format here can be a little confusing, but I'll go over it. So the kind is workspace, and this is a custom resource that is created when you install the operator, or the Helm chart, I should say. It includes this custom resource. Now, the workspace name is in this metadata name field. So vnet new is going to be the name of the workspace that gets created. In the spec, you have to include your organization name. Mine's just Net in the Cloud. I know that's exciting. By default, you have to tell it where to mount the secrets. So it's going to find that workspace secrets, Kubernetes secret, and it's going to mount it at this path so it can read the values in. That's how it gets the values that you have stored in that secret. And then in our case, I'm going to reference a module for deployment, and this is one that I created myself at this GitHub address. And this is open source. You can go ahead and use it. All it does is create a VNet with some standard addressing, and it creates a resource group for that VNet to live in. It's very straightforward. I couldn't use the one directly out of the published modules because that requires you to define a provider, and this doesn't define the provider. So that's a whole other aside. All right, what else is in here? Well, you can define some outputs that you can interact with. So for this one, I'm defining an output, and the key is how you refer to it within Kubernetes. The module output name is the actual output from your Terraform configuration. So that's how you match those two up. Under variables, here's where you submit variables that will be used within your configuration. So each one has a key, and that key should map to the name of the variable in your configuration. So I have a variable called resource group name, and I can directly give it a value, just give it a value right here, and that's the value that it will use or if you don't specify a value, it'll use the default value. And then there's some other fields here. Sensitive, we're gonna say false. And then environment variable, I'm not defining this as an environment variable for the run of the workspace. So I set that to false, and it will just submit it as part of the configuration. The next one is going to be an environment variable. It's our client ID. Now, where is it getting this value from? I'm not going to define it directly in this config because that's not very dynamic. Instead, I'm going to say value from a config map key reference. What's the name of the config map to reference Azure configuration? And then which key should it get its value from? ARM client ID. So it's going to look for that config map. It's going to pull the value of that key out, assuming it finds it, and it's going to use that as an environment variable in my configuration. So I set sensitive to false because it's not a secret. It's just an environment variable. I'll do the same thing for subscription ID, do the same thing for tenant ID, and then for client secret, I am going to set sensitive to true. And when sensitive is set to true, instead of looking in a config map or anywhere else, it's going to go look in the secrets that we mounted at that path /temp/secrets for this key. And if it finds it, it's going to use it. So actually, no, we're good. Okay. Sorry, when I created that secret, I actually should have called the secret the same name as this. So, hey, look, I found an issue while I'm doing this. Isn't that exciting? So this should map to this. So ARM client secret should equal client secret. I'll go ahead and save that for later. I've already deployed that config map with the correct information, so it should be fine. But so it's going to look for that key in the secrets that's mounted at that temp path. And if it finds it, it will use that and load the information from there. Sensitive is equal to true. Environment variable is equal to true. This last one allows you to destroy the workspace when you're done. We're not going to destroy it first. We have to actually apply it. So that's the configuration. How do you actually create the workspace? So glad you asked. We're going to do kubectl apply -f, and we're going to do vnet YAML. So that's the vnet YAML that we just looked at in the namespace tfops. We'll go ahead and apply that. And it's going to go out and talk to the Terraform workspace and create this run within that Terraform workspace. So let's go over to the browser and we'll go to my organization and we should see, there it is, tfops vnet new. That's the name of the workspace that we gave it. And if we click on there, we can see a run is currently executing. We can open up the execution. We can see that it's running through plan right now. And because it's using the operator, when the plan is complete, it automatically applies what's in that plan. It doesn't wait for you to approve it. That's probably important for you to know when you're using this operator. It doesn't wait for you to approve the plan. It just kind of does it. So now the apply is running and it should complete pretty quickly because it's creating 3 subnets in an Azure VNet. There's not a lot going in here. There we go. Apply is now complete and finished. So it went through the entire process. If we go back, we can run Terraform describe workspace. And this is going to, so the resource type is workspace. If we do kubectl describe workspace, the namespace and the name of this workspace, it should tell us at the bottom the status of this particular run. Now, right now, it's saying it's still applying because it probably hasn't gotten the feedback from Terraform Cloud that the apply has completed successfully. But there we go. We run it again, and now run status is applied. So it knows that everything's hunky-dory. If you want to update this configuration, you can change something about this VNet YAML config, or you can change something about the secrets or the outputs, and that will force an update run of whatever's in that workspace. And that's pretty well documented. If you're done with it, if you want to destroy it, all you have to do is do kubectl delete the resource and hit enter. And you absolutely have to have this down at the bottom, the confirm destroy value 1. If that is not set, it will not destroy the workspace. So let's go back to the workspace. If it hasn't already, it's going to kick off another run. Okay, so it's in the destroy run. While that's running, let's take a look at the variables. We can see here's all the environment variables that I set. And I'm going to delete all this, so don't worry about the values that are in here. But we can see that the ARM client secret is in fact sensitive and write only. So we can't read the contents from here. We only know that it exists. And confirm destroy is set to 1. And then that one variable we sent for resource group name is set to tfops vnet new. So that's where all the variables got set. And if we go back to this workspace, it's still in the destroying part. Once this is complete, it will not only destroy the infrastructure, it's actually going to delete this workspace. So, tread lightly if you're going to do that. So that'll go through its process. This will sit and wait until that deletion is 100% complete and then hand you back the command line. So don't Control-C out of this. Just let it do its thing and it'll get there. So that's everything. That's all I have for today. I know that was a little bit longer of a video, but I really wanted to get all the information in there about this Terraform Kubernetes operator, kind of what it does. Like I said, all of this code is available on my Terraform Tuesday GitHub repo. So if you want to follow along or try this out yourself, absolutely go for it. And you can kind of riff on it and create other examples. I didn't even get into the actual spec for the workspace, but you can find that if you go to the browser and you dig into some of the code on GitHub, you can find the actual spec or the custom resource definition for that workspace and figure out kind of what some of the options are when it comes to things. So, like I said, that's all I have for today. Thank you so much for watching. I hope you enjoyed it. I'm looking forward to doing a completely different one on next Tuesday. And until tomorrow, stay healthy and stay safe out there. Thanks.